Okay, here we are for section 2.6, which is modeling with our functions. And basically what we're doing today is we're going to be taking all the stuff that we've learned from 2.5, and everything we've learned previous, and we're going to use it to set up models that are more for real world situations, okay? And we're going to start just by practicing how to write some equations, and then on the back side of this, we're going to be actually solving things for like maximum and minimum values. All right, so things that you need to do for me every time that you do a problem like this is you have to start by defining the variable. Okay, that basically means like usually I use an x, you don't have to use an x, sometimes I tell you, radius, you might want to use r or something like that, but you're going to tell me what my variable is representing. So basically I'm going to say whatever my variable is and I'm going to describe it using words, okay? Kind of like when we're writing a word problem. Then you're going to set up the model, and the model is an equation that's going to be how is your variable related to everything else, like what would make sense. Sometimes it's an area equation, sometimes it's a volume equation, sometimes it's something totally different. Okay, and then you're going to use that model that you wrote in order to answer the question. And so this is basically on the back side, but usually it's going to ask me to find either a maximum or a minimum. And haven't we really just been doing that previously, right? In section 2.5, we found the maximum or the minimum by finding the vertex. So same idea here. Okay, so let's practice. First of all, it says, find the function that models a real life situation. So it doesn't tell me I have to find a max or a min, I'm just gonna set this up. So it says I have a rectangular building lot that is 3 times as long as it is wide. Find a function that models its area in terms of its width. Okay, so I have a rectangular building. Oftentimes I'm going to draw a picture for this. And I'm going to call this my length, and I'm going to call this my width, okay? And it says that my lot is 3 times as long as it is wide. That means I don't know anything about the width. So what I know the least about is what I set my variable equal to. I know nothing about the width, it's x. But what do I know about the length? I know it's 3 times as wide. So I would write that as 3x. So now both of these are written in terms of x. I only use one variable here instead of using like a w and an l, okay? But my whole idea here is about the area. And the area of a rectangle is, generally speaking, length times width. Well, I only want it in terms of w, so that's what I wrote here. So my width is x and my length is 3x. So area is equal to 3x times x, which I could simplify. So I write area is equal to 3x squared. And that's all it's asking me for, so I'm finished. Okay. Number 2. The sum, what does sum mean again? Answer to an addition problem. The sum of 2 positive numbers is 60. So when I add those 2 numbers up, I'm going to get 60. Find a function that models their product. What is the product again? When I multiply them, okay, in terms of x, one of the numbers. So in this case, it's even a little bit different. They even say to you that x is one of my numbers. And so I'm going to say, okay, x equals one number, or maybe I'd write it as my first number or whatever. But how do I write my second number? Well, I have to go back to this part right here. It says the sum of 2 of them is 60. So if I add them both up, I get 60. Or if I take 60 and I subtract the first one, that would be my second number. Does that make sense? Okay, so then I'm supposed to use this to talk about their product. So I'm basically taking the first number times the second number, and I'm going to get their product. Okay, so What is my first number? X. What is my second number? 60 minus x. That's equal to the product. And I could simplify that a little bit. I could distribute that, which gives me a 60x minus x squared is equal to the product. And that's my answer. Okay, good. Let's look at number 3. A little bit different here. It says the height of a cylinder is 4 times its radius. Height of a cylinder is 4 times its radius. What's a cylinder? Cylinder is circle on the top, circle on the bottom, kind of like a can of soup or something, right? Can of soda. So the height of a cylinder, my height goes from the center of the top to the center of the bottom. We're going to call that my height. And the radius of the cylinder, all right, goes from the center of that circle out to the outside of that circle. So that's my radius. All right. So it says, find the function that models the volume of the cylinder in terms of the radius r. So we already know that r is my radius right here. And what we're saying is that we want everything to be in those terms. So way back here, it told me that the height of the cylinder is 4 times its radius. So I know the height is the long part, but that height is also 4r, okay? And here I'm defining, right? Right there I said r is my radius, and so h is 4r, so I could say that's my height is equal to 4r. I don't know if you really need that since you already have it written in the picture. But then we're going to go right back here. We want the volume V of the cylinder. Well, that means we have to know what the volume formula is. And I don't know if you remember this from geometry, but if I'm taking the volume, I basically take the area of the base shape and then I multiply it by the height. So that base shape is a circle, and that area formula is pi r squared, and I multiply that by h, okay? So the volume formula for the cylinder is pi r squared h. Okay, well, now I'm supposed to write this only with r's. So my volume is equal to, pi is a number, so that's just gonna stay. R is already r, so that's r squared. What is my height, though? We said the height was 4r. So now I'm just going to multiply all that out. 4 is a number, pi is a number. I've got r squared times r, that's r to the third. So my volume is equal to 4 pi r cubed. Good. All right, on the back side of this. Now we're going to put some stuff together to actually solve for things like maxes and mins, okay? So it says use the guidelines above to answer the questions below. So in this first one here, it says that I have a gardener that has 140 feet of fencing to fence in a rectangular vegetable garden. All right, so we are just thinking about that, and I'm going to kind of draw my rectangular vegetable garden, and if I fence that in, it basically means the perimeter of that rectangle, right? It has to be only 140 feet. Okay, so the first part of it is just like what we did before. It says find a function that models the area of the garden she can fence. So what do I know? I know I have a length, and I know I have a width, okay? And we know that this 140 feet is the perimeter. So if I say, well, my perimeter is actually all the way around, so I have the length on the bottom, the width on the right, I have a length on the top and a width on the left, that's like saying 2L plus 2W. And I know that my perimeter is 140, so I can actually say 140 is equal to 2L plus 2W. Okay, now I need this to only be in terms of one of my variables, because I know that the area of the garden is the length times the width, just like it was before, but I don't want an L and a W. So I need to go back to this equation over here, and I need to solve for one of them. Okay, so let's solve for L. It doesn't matter, you could solve for either one, but if I solve for L, I would take away the 2W, which would give me 140 minus 2W is equal to 2L. And then I would divide everything by 2. So that would tell me that 70 minus W is equal to L, right? Because those are going to cancel. So now, when I go back to the area formula, and I say, well, my area is length times width, I can replace the length with 70 minus W times my width, which then means I could distribute that. So my area is 70W minus W squared. Okay, so that's exactly what we did on the first page. It got a little more complicated because I gave you what the perimeter was. I had to fill that in and solve for one. Okay, but now this area formula is true or works for this garden. Now, it says for what range of widths is the area greater than or equal to 825 square feet? Okay, so here's what we're saying. We're saying that my area, okay, 70W minus W squared, that area, I want to know when it's greater than or equal to 825. Now, this is a little tricky, but this is a quadratic and it's an inequality. So this means to solve it for W, I've got to get everything on the right, make my 0 on one side here, and I've got to, well, yeah, okay. If I move everything to the right, I'm going to say 0 is greater than or equal to, I'm going to move the W, so that's positive W squared. I'm going to subtract the 70W, and that's plus 825. Now, this being a quadratic inequality means that I'm going to need critical values. And generally speaking, when we did this, we said that all of this should be on the left and that my 0 should be on the right. So I like that better because of how this sets up. So I'm going to rewrite that. I'm going to write W squared minus 70W plus 825 is actually less than or equal to 0. And I didn't just move everything to the left, because if I did, I would still have had my negative in front of the W. You could have, but then you would have had to divide by -1 and switch the sign and whatever. Lots of ways to get that answer, only one answer. Okay, so then to do this, I need to find my critical values by factoring. Or you could use completing the square or something like that. But I'll help you out here. Factors of 825 that make a -70 are 15 and 55 if they're both negative. So when I multiply that together, I'll get a positive 825. When I add those up, I'll get that -70. So what does that mean for me? It means that my critical values are positive 15 and positive 55. And that means that they go on a number line. And then I ask myself, are these open or closed circles? Answer should be closed. And then I have to do some test points. So when I test, like 0, that's way over here. When I put in a 0 back over here, I'm going to get a negative times a negative, which is a positive. If I put in something like 20, which is between 15 and 55, 20 minus 15 is a positive, 20 minus 15 is a negative, so that's going to give me a negative in here. And if I choose something like 100, that's in the last section, that's going to give me a positive times a positive, which is positive. And then I go back and say, well, what am I looking for my answer? I'm looking for things that are less than 0, which means negative, so that's in here. So what is the range of values? It's the range between 15 and 55. The range of widths that create an area greater than or equal to 825 square feet are between 15 feet and 55 feet. Okay, so that's cool that you could figure that out. Like if you're really building this garden and you want 825 square feet to grow all the vegetables that you need, you could figure out how big the width would be using that amount of fencing that would help you do this. Okay, now what if you wanted to find a garden? What if you found some more stuff you wanted to plant and it says, could you fence a garden with 1,250 square feet? Okay, so again, I'm using that area formula and I'm saying like 70W minus W squared. Can I make that area equal to 1,250? Well, to do that, I would have to, again, set this equal to 0. So I'm going to make that W squared minus 70W plus 1,250. I could maybe try to factor that. I believe I tried factoring that and didn't come up with anything nice. So if I can't factor that, then I need to use one of my other two options. I could complete the square or I could use quadratic formula. So if I use quadratic formula, A is 1, B is negative 70, and C is positive 1,250. So I'm really solving for W here. W is equal to negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. And when I do that, first thing I do is I go inside and I do my discriminant. So negative 70 squared is 4,900. And when I multiply 4 times 1 times 1,250, I get 5,000. So what happens when I take 4,900 minus 5,000? I get a negative 100, which means that this is imaginary. What does that mean for my problem? It means it's not possible, right? I can't get a garden with 1,250 square feet. So you're going through, you're saying, well, I need at least 825 square feet. What would that look like? Okay, can I get 1,250? I want to fit pumpkins in there and they need some space. No, I can't get 1,250. So the next logical question is, what would be the largest area I could fence? So think about that. Largest area means a maximum, okay? A max area with that information. So let's go back to the formula that says my area is equal to 70W minus W squared. If I said to you, what is that function going to graph? Hopefully you tell me that's a parabola and that the parabola actually opens down because this is a negative value. So what is this up here? It's my max value. And I can find that max value the same way that I've been finding my max value for the last couple of sections, right? I want to find my vertex. So to start with my vertex, I'm going to say the x value of my vertex. And by the way, what one of these, area or width, is considered my x, like x and y? It's definitely going to be the W, isn't it? So my vertex, so I'm solving the x value of the vertex is W equals negative B over 2 times A. Well, we did A and B and C earlier, so I'm going to say that's negative 70. Oh, wait a minute. Yeah, negative. Oh, okay. I was using my A and B from up here when I move stuff around. If I'm just going right here, A is equal to -1, B is equal to 70. It doesn't matter if and C is equal to 0. And it doesn't matter if I use these or if I use these, but I have to stay consistent. Okay, so let me erase this little piece right here. Okay, so if I'm using these, -70 over 2 times -1. Well, that's going to give me a positive 35 is equal to my width. So to get my max area, my width is going to be 35 feet. What would be my max area, or how do I find it? I would have to take that and I'd have to plug it in here. So the area is going to be 70 times 35 minus 35 squared. So 70 times 35 is 2450. 35 squared is 1225. That gives me 1225 feet squared is my max area. And again, I'm finding that by finding the vertex. That vertex would occur at 35 feet wide, comma, 1225 feet squared. All right? Hopefully that makes sense.